and I'm recording. It's going. So this is all about combinations. I wrote combinations and combinations. That's should say composition. Composition. So this is the topic. This is section 1-5. Compositions, not combinations. Compositions of functions. So let f and g be functions with overlapping domains, then for all x common to both domains. And I'll explain what that means in a second. F, I better look at my notes. And tell me if I get in your way, just push me out of the way. F plus g of x, f plus or minus g of x is equal to f plus g of x, like this, is equal to f of x plus or minus g of x. And I'll give an example of each one of these things, okay? And all that means, if you want to know what, the way I add the two functions together is I'll explain to me, okay? So you'll see. So this means f plus or minus g of x. This means f times g of x is just equal to f of x times g of x. And this means f divided by g of x is equal to f of x divided by g of x, provided g of x cannot be equal to 0, otherwise the function is undefined. So all that means is, if you know what one function is, so for example, if I have f of x equals, where's my f of x? X squared plus 2x. X squared plus 2x. And g of x, this is called function notation, by the way. G of x is equal to 2x plus 1. 2x plus 1. And f, this stuff is really like, duh, you know, why, of course it is equal to, all you do is you add the two things together, okay? So that's equal to x squared plus 2x plus, probably in parentheses, 2x plus 1. And then you just simplify that, which simplifies to x squared plus how many x? Hello, how many? 4x plus 1. So that's f plus g of x. That's all that's it. And another way you can think of it, if I plug in a number, so if I said f of 2, what would f of 2 be? F of 2. What's f of 2? F of 2 says take 2, plug it in there. Alright, so that's 2 squared plus 4. So f of 2 is 8. Yep. What's g of 2? What's g of 2? 5. So if I take 2 and plug it in here, I get out 5. Anyone not familiar with that kind of notation? All right. So what's f plus g of 2? What's f plus g of 2? I could just either, so what this says is I can either add those two things together, guys. 8 plus 15, I get 13, or I could take 2 and plug it into the formula for f plus g of 2, which is, so if I take 2 and plug it in here, I'm going to get 4 plus 8, which is 12 plus 1, which gives you 13, which is the same as if I would have done that. Okay? And it works the same way for addition or subtraction, and it works the same way for multiplication. Let's just do an example with multiplication. And do I have one for, and I do have one for division. Now, in this case, that thing about common to both domains, that thing doesn't matter, right? Because what numbers can I plug in? What numbers can I plug into here? what kind of numbers can I plug into there? Any numbers. Can I plug in any numbers in here? Yes. So that issue of domain, it doesn't really matter there. But when you have like things like square roots and things where you have rational functions, where you have functions in the denominator, like I'll show you an example in a minute, then you kind of have to worry about the domains of f and g and that kind of stuff. So I'll talk about that in a minute. Right? We're good with that? Should I move on? All right. So I'm going to give you an example of multiplication now. So new page. And so now, so also let's do multiplication. Oh, I have to write down my f of x and g of x again. So f of x again was f of x was x squared plus 2x, x squared plus 2x, and g of x is equal to 2x plus 1 and 2x plus 1. So f times g, that's f times g of x, and make sure you make that a little dot, and or you could just put them right next to each other, which is the same as saying f g. They could do like this because that implies multiplication. That's equal to x squared plus 2x times 2x plus 1. And all you do is, so then they would want you to simplify that. Okay? And so you FOIL, just like you would if it were just a quadratic. So you multiply the two first together. What's that give you? 2x cubed. And then you multiply first outer. What do the outers give you? This times this. X squared. And the inner gives you 4x squared, and the last gives you 2x, right? And then you would simplify that, so it's 2x cubed. Am I in the way? 2x cubed? That's why I have a screen up here. Plus 5x squared plus 2x. And that's all there is to that. And again, in this case, the domain, you don't have to worry about the domain or anything like that, because both of those you could plug anything into them. It's not going to make any difference. But what if I have something like, so I came up with different examples to get you confused. So what if I have f of x equals square root of x plus 1. And g of x is equal to g of x is equal to x. What's going to be g times f of x? What's that going to look like? G times f of x. What's that going to look like? I'm going to pick on you. Someone doesn't raise their hand. What do I do with those? You don't have to really multiply it out. Okay? All you have to do is it's just, what's g? X. And that's just x plus 1. And there's really nothing you can do with that other than just leave it. But what's the domain of, so what's the domain of g times f of x? What numbers, what has to be true about that thing in the parentheses? I mean in the square root thing. It's got to be positive. So the way you would figure out the domain, you have to say x plus 1 is got to be greater than, not just, it could be 0, right? Couldn't it be 0? So if you say x plus 1 is greater than or equal to 0, so what's got to be true about x? X has got to be greater than or equal to negative 1. Okay, in order to make that a positive number, 0. So that's what they mean by domain. Now, in some cases, it gets tricky, because say g of x, I'm just going to, well, we'll worry about that when we get to the compositions of functions, all right, which is the next thing. And then I didn't do a division one. I could do a division. What is, well, let's do this one. What is f over g of x for the same two functions? What's f over g of x? What would that look like?
But just the same, like
Square root of x plus 1 over x. What's the domain of that function? Okay, so in this case, it's trickier because the domain, in this case, first it has to be f of x. You have to find the domain of f of x, and then you have to find the domain of g of x. Well, the domain of g of x is all real numbers, but when I put it down here, f of g of x, this is going to make, 0 is going to make that function undefined, right? And so the domain is x is greater than -1. Do you guys understand why it's got to be greater than, not equal to? Because if I plug in 0 in here, this function is going to, you can't have 0 in the denominator, it's undefined. Yes? Well, okay. Good. Okay, I'm done. Phew. You need to hear a joke now? So that's called combinations of functions. Have you seen that before? You guys have probably seen that before. Okay, so now we have compositions of functions. Am I going? I'm going. So compositions of functions, which can be a little bit more compositions of functions. And this is when you see stuff like f, so it's written a little bit differently. It's f of g of x, like that, which is equal to f o, there's a little, that's like a bigger dot with a hole in it, okay? So, and sometimes they write it just like, I think you have to go like that. It looks like fog, right? But that's a little open circle. It's f of g of x, okay? And this this function over here, okay? This is called, so g in this case would be called the inside function, okay? Inside function, and f would be called the outside function for obvious reasons. Okay? Outside function because one's inside and one's outside. And f of g of x, this is again is the inside. This means the same thing. Right? So basically what you do with f of g of x is you plug g into f. Have you done that before? Yes. You've done that. So you did this in algebra too, right? So it's okay, we're just picking it up here. So say, for example, are we doing the same? I guess we're doing the same functions again. Or maybe this isn't the same function. So say, for example, f of x is equal to x squared plus 2x, x squared plus 2x. And g of x is equal to 2x plus 1. 2x plus 1. Who could tell me what f of g of x is? What's f of g of x? I don't remember if you have to put this part in parentheses or not. I don't think you do the first part, but I do. So what do I do with that? Yes.
2x plus
Man.
1, all of that squared, plus 2 times.
Good. So what this says basically is you take this, right, and you plug it into this function everywhere you see an x, right? Okay? And so this you go 2x plus 1, just what Madison said, 2x plus 1 squared, plus 2 times 2x plus 1. Do you see where we got that from? Everywhere you see an x, you plug in 2x plus 1 because that's g. Okay? And so now what you got is 2x plus 1 squared. Who can tell me what that is? What do you think that is?
I just get 4x squared plus 4x plus 1.
Ah, good kid. Don't forget those middle terms. 4x squared, I was hoping you were going to say 4x squared plus 1, but you did. Good. So it's 4x squared plus 4x, right? Because you have to forget, don't forget the outer and inner term. Plus 1 plus, then you distribute this. 4x plus 1, 4x plus, not 1, 2, right? Distributive property. And then you can combine like terms, which gives you 4x squared plus 8x plus 3. Yes? What would G, I'm going to try to vary it, G of f of x look like? What would G of f of x look like? Just for kicks. Not the same thing.
Oh, so this is the opposite?
Yeah, so what would I do in this case? G of f of x. So this is just this reversed. Who can tell me? Go ahead, Sam.
It'd be 2 and then parentheses x squared plus 2.
X squared plus 2x, right?
Just 2. Or, I'm sorry.
No. Because in this case,
Yeah,
you're
plus
taking,
2x.
you're
Sorry,
taking
that's
this
plus
whole thing and plugging it in here
Yeah.
for x. Not done yet. What
Then
else?
plus 1.
Plus 1. You guys see where you got that from? Yeah? So what you're doing in that case is you're taking this and putting it in here for x. And then you would simplify. I'm not going to go through that and find. Now, this, it's real important for when you get to calculus, because when you get to calculus and you do derivatives, you learn about something called the chain rule, and you have to know which is the inside function and which is the outside function and stuff like that. So sometimes it's like sine squared of 2x or something. You have 3 functions inside each other, and it gets kind of fun when you get there. Okay. The other thing they like to do is go backwards. Okay. So sometimes we don't like red, do you? It's kind of threatening. So say I have this. If h of x, this one's kind of tricky that they gave me as an example. If h of x is x plus 1 squared minus x minus 1, okay, or f h of x equals, okay, then find 2 functions f and g such that f of g of x is equal to h of x. Well, so in this case, what you're doing is you're going backwards. All right? So how can I break this into two functions? You have to be kind of clever on this one. Kind of tricky because it's not. Ideas. What is it? What? Give me a minute to think. Anyone?
Is it like g of x equals x plus 1 because it's like inside?
That girl is right on it. Okay? So, yes, that's what you do. You say that. You have to be kind of clever still, though. So if g of x is equal to x plus 1, okay, what can I plug x plus 1 into to get this expression?
X squared minus x.
X squared minus x. You see, so that probably what you want to do is rewrite this as x plus 1 minus x plus 1 squared minus x plus 1. Do you see that? See that? So this is equal to this. Then I say, there's an x plus 1 in both of these pieces, right? Then I could write f of x as what? F of x is what? X squared
Minus
x squared minus x The one,
The last one.
the last one, this last one,
Yeah.
it's taken care of, right? Because this is g of x here, right? That's g of x, and this is g of x also, right? Is x plus 1. So what I'm doing, I'm taking g of x and plugging it in here, and I would get this, right? And if I take g of x and plug it in here, I would get this. See? No. Because
Oh, to distribute the negative?
yeah,
Okay.
yeah, I pulled that. So it's not always as tricky as that, okay? Because they gave that as an example in the book and in my book, and that's kind of a tricky one to start. More than likely, they'll give you something like this: h of x is equal to the square root of x cubed minus 2 or something like that. So you could say that f of x. So if you want g of f of x, you could say that f of x is x cubed minus 2. What would g of x be? It would be like square root of x. So h of x could be g of f of x. Like that? Yeah? No? Yes? Maybe? So this is going backwards. So going backwards is harder than going forward, right? Because you have to kind of decipher it. So find the domain of g of f. Find the domain of g of f. G of f. Okay, so here's where it can get kind of tricky. Okay? Say I have, I'm going to kind of make this one up because I don't like the example that I came up with. Say you have that f of x is equal to the square root of x, okay? And g of x is equal to 2 over 2 over x plus 1. No, that one. Minus 1. Minus 1. Okay. Find g of f of x and its domain. I want to kind of making this one up, but I want to make sure. I think that's going to work. Okay. So what's g of f of x? 2 over square root of x. Right? I'm taking this and plugging it in here. Minus 1. Do you guys see that? What's got to be true about x?
It has to be irrational.
It has to be,
Or you can't have roots in the denominator.
you can't, no, well, that's okay. I mean, that's just more like, that's more just like by convention, Sam. You're allowed to, it's just, it's just not proper, okay? But this is a minus. So this is g of f of x, okay? The domain, what's the domain of f? Domain of f. Domain of f.
X is greater than 1.
X, well, x has got, what?
Minus is greater than or equal to.
No. What has to be true about x?
Has to be positive and
Great.
greater than 0.
Greater than or equal to 0, right? So x has to be greater than or equal to 0. So this is where it gets tricky. That's pretty easy. I just say, well, I'm plugging a number into here first, right? And this number has to be greater than or equal to 0. But also, what can this denominator over here not be?
0.
What would make that thing equal to 0? 1. So what else can x not be?
1.
So x has got to be greater than or equal to 0. And also, x cannot be equal to 1. Do you guys understand why that is? Okay? Because, first of all, you have to look first at what kind of values can I plug in here? Then I have to look at the composite function to figure out what kind of values of x are going to make my composite function undefined. See? Okay, and even though it says these numbers have to be greater than or equal to 0, this square root of x cannot be equal to 1, so the thing that gives you square root of x equals 1 is 1, right? So it's kind of weird. Okay, so that's a lesson. The other kind of problem I like, one more type of problem that I think is fun, and this is a good problem for thinking, kind of more like thinking. So if this is, and I made this one up, I like to make things up, f of x, and this is g of x. All they'll give you is a table. So this is a good like conceptual problem. And here's x, and here's y, and here's x, and here's y. And I just made up some numbers. I said when x is 1, y is 3. When x is 2, y is 0. When x is negative 1, y is 6. When in g of x, when x is 1, y is negative 1. And they love to give you these kinds of things on like ACT tests and stuff like that because they're more conceptual than mathematical. Okay, and they do this with graphing too, and you'll probably see a couple of things in your homework like this. So what's g of f of 2? G of f of 2. G of f of 2. Who thinks they could tell me how to do that? Go ahead.
Well, you can find the values in the table, so you go to f of 2, and that's 0, and then g
F of 2 is 0, right?
yeah, and then g of 0 is 7, so.
Do you see where he got that from? So it's like, so f of 2, if I look at, I have to look at the function f, right? So if I take whatever that function is, there's some machine, right? So here's the f, f function, and here's the g function, okay? So what this says is, if whatever that function's doing, it says if I put in a 2 in here, I'm going to get out a what?
0.
A 0, right? And now it says, okay, I'm going to take that 0 and plug it in to g, and what am I going to get out of there? A 0, I have to look, now I'm plugging into g, and the g is going to return a 7. See? Kind of like you get change out, and then you put your change into a different vending machine, you know, or maybe you, like bartering, you know, where you put in your 50 cents, you get out some chips, and then you trade those chips in with someone else for hamburger. I don't know. Okay, what's f of g? That's an of. F of g of f of g of 1. Okay, f of g of 1. Oh, who did that so fast? Who did that so fast? Very good. F of g of 1 is 6. So first, in this case, now I'm going to g first, right? So I'm going to g. I'm taking 1. I'm getting out negative 1. Then I have to take that answer and plug it into f, right? And I get negative 1. And when I plug in negative 1 into f, I get out 6. You guys get that? That's really good kind of conceptual. You know, it's like, you know, anyway, that's kind of it. So there are word problems, a couple word problems that I think you guys will be able to figure it out. And I think that's enough kind of lecturing at you. So I'm going to just, you have a long time, right? How long do we have? 40 minutes? What time do we get out? 18, right? And so I'm just going to give you the rest of the time to work. If we get too restless at the end, maybe we'll play Two Truths and a Lie. That's fun. Okay. So,
How are we
so,
going to do like homework charts?
What?
Do you collect homework every week?
I collect homework pretty much. It depends if I could get a student assistant or not.
Okay.
So sometimes I might just look at it.
Okay.
But usually on a daily. No, I don't collect it as a pack. I have in the past just
Okay.
collected packets, but and I get lost. So we'll see. So your homework, if you go to my website, it lists the homework there. I'm just going to grab it. This is what I like to do. And don't forget to tell me to stop recording. Pre-calc assignments, go to chapter 1. And this is it. This is today, right? Composition, to books distributed, composition of functions. And here it is. Place, capture, and new page. So I'll make that big so you can see it. Now I'm going to stop recording. And